Hi everybody, today's lesson is for day 3 of Explain, Seeing and Hearing. Do a little video lesson on how do waves help us see and how do waves help us hear. So looking at light, you guys have been looking at that light travels in a wave, and depending on the wavelength of that light is going to be if we can see it or not. So we have all of these wavelengths. We have really short wavelengths that have really high energy and longer wavelengths with lower energy. And right in the middle, the human eye has developed just this small wavelength of light that we can see. So when we see those different wavelengths of light, we see different colors, but know that there's a lot more light that we can't see. Yesterday, you guys went through and you watched this crash course video and went through the anatomy of the eye a little bit. I just want to refresh your memory. When light enters our eye, it first passes through the cornea, which is a clear outer covering that protects our eye from dirt and dust and debris so that we don't get anything in our eye that's not supposed to be there. Once the light passes through the cornea, it's going to enter the pupil, which is that black dot in the middle of your eye. And it's basically a hole that all the light can go into. The pupil is surrounded by the iris, which is the colorful part of your eye. I have brown irises. My son has blue irises. You might have green or hazel. But that is the part that is going to control how big the pupil is. So the pupil doesn't actually dilate. The iris is the one that's doing the changing of size. If you're in a really low light situation, like a really dark room, your iris is going to open up to let a lot of light into your pupil. But then if you were to go outside on a sunny day, your iris is going to constrict down so that not too much light is getting into your eye, because that too much light would damage the interior of your eye. So the iris is what's in charge of controlling how much light enters. Once the light enters the pupil, it is going to go through the lens. And this is a very important part because in our eye, all the light is coming from different directions, and we need it to focus back here on this back part. And that lens, its job is to take all the light and kind of direct it towards the retina so that those light waves can focus on that one specific part of our eye. Some of our lenses don't work quite right. So if you are a glasses wearer or a contact wearer, your lens is to blame. The lens is going to focus all the light on the back portion of our eye, which is called the retina. And the retina contains all the light receptive cells, so rods and cones. Rods are to detect dark and light, and cones are there for color vision. And then, there we go. After the retina gets the message, it's going to transmit those wave messages to the brain through what's called the optic nerve, or what comes out the back part of your eye. So light's going to travel through different things to get to the retina and then up to the optic nerve. Because we have these different properties that light waves have, it allows us to see images. So we couldn't see if light didn't do these two specific things, and one is reflection. So when a light wave is traveling, if it hits something, it will bounce off of that and then bounce back in a different direction. So for here, the sun, the light's coming off the sun, it's hitting the apple, and then the light is changing directions and bouncing into this person's eye. This is a very obviously simplified picture, but if light didn't bounce, if light was just absorbed by objects, we would never see, and we would also never see color. When all this light is coming off the sun, all of those different wavelengths are traveling. That is white light. The apple is going to absorb all the wavelengths of light except for red, which bounces back, and we are able to see the color red. All the videos in here I will put on Brightspace if you are curious about what it's like to be colorblind. That's kind of an interesting video. So reflection, or bouncing back of light, helps us see, and specifically see color. And the other thing that light does is it bends. So when light travels through different mediums, so like air, water, glass, anything that's transparent that light waves can go through, anytime it transfers from one medium to the other, there's going to be a little bit of bending or refraction that occurs. When light enters your eye, the cornea is going to bend it a little bit. The lens is going to also bend the light, and hopefully it bends it perfect so that it focuses on your retina. If it doesn't, that's where you have to wear corrective glasses, where you put one other medium in front of you. So my glasses, when the light enters my glasses, the glass is a medium that bends the light. The lens bends the light, so it focuses on my retina. This is a really good video to watch. I'm going to post that one on Brightspace too. That's just about how glasses help us see and the different kind of vision problems that humans can have. Moving on to sound waves then. So sound waves are different from light waves because they are a different type of wave, and they require a medium so that they can vibrate that medium and the sound can pass through. So just like when light enters our eye, there's a specific path it travels through, hearing is the same. Those sound waves, those vibrating particles are going to enter into our ear and go down the auditory canal, which is filled with air molecules, which will vibrate. Those air molecules will vibrate the tympanic membrane or the eardrum. And then that's just going to set forth another series of vibrations until we get to some kind of receptor that helps us decode the sound message. So from the eardrum, we're going to have three little tiny bones. The anvil, hammer, and stirrup. Their scientific names are there for you too. They all vibrate and eventually vibrate this swirly looking thing here called the cochlea, which is a tube that's filled with lots of little hairs that pick up those sound messages and sound messages to our brain. We also have an organ in our ear called the semicircular canal, which tells our body which direction we are. So if you are standing, it tells your body you're standing. If you were to be upside down, you know that because of the liquid in the semicircular canals of your ear. If you get motion sick like I do, that's because this little guy is kind of messed up and sometimes tells our body we're moving when we're not. And then finally, there's this tube. It's called the eustachian tube. If you get a sore throat, often your ears will hurt too. Or if your allergies are bad or your sinuses are bad, you kind of get an achy ear. That's because this tube here is connected to your sinuses. So whenever I get a sore throat, my ear hurts too. That's because of this tube that connects the two. Properties of sound, a couple things. Sound waves must travel through a medium. They have to have something to vibrate. They cannot travel if there is nothing to vibrate. There is different intensities of sound. So you all know that some sounds are loud and some sounds are quiet. The greater the amplitude of the sound wave, the more energy it's going to carry and the louder the sound is going to be. Those little hairs in your cochlea that help you pick up messages, sound messages, they eventually will get kind of wore down or broke off. So the older you get, you might have noticed older people have a harder time hearing, especially higher pitched noises. This is because they've had that wear and tear on those little hairs in their cochlea over time. This is always my plug of wearing the AirPods or the in-ear headphones. Just be careful that you're not blasting your ears and ruining your sound receptors before or too early on, because you're going to need them for a lot of years still. And then finally, pitch. Pitch is going to be determined by the frequency or how fast the vibrations are happening. So the faster something vibrates, the higher the pitch will be. And we have a range of hearing within certain pitches. So just like we can see just one small chunk of the light waves, we can only see visible light. We can only hear between 20 and 20,000 hertz. Below that would be called infrasound. So this is like some, I think you read, or on Monday there was something about whales. They can hear really, really low pitch sounds. And then above 20,000 is called an ultrasound. So I'm actually going to get an ultrasound today. So ultrasound is a medical procedure that uses sound waves to bounce off and reflect off so that you can see things inside your body, like growing babies. So I'm getting an ultrasound today so that we can measure everything and see how baby Mosley number 3 is growing. If you could hear ultrasound, this would be a really annoying procedure because it would be very loud and very high-pitched and uncomfortable. But luckily, my ears cannot hear it because it's out of my range of hearing. So that's all for today. Just a brief little touch on how do waves help us hear and how do waves help us see. I'm going to post all those videos that were in this slideshow so that you curious people out there can watch some of them. I really highly recommend watching the one about eyeglasses. It will help you better understand about the properties of reflection. Have a great day, everybody, and I will talk to you soon.